if I had the other day I showed you this. If I had a fraction as my exponent, I can rewrite it as a radical, all right, which is where you have a square root value or a rooted value by taking this and making it my index. So I put my index here, and that becomes a to the third, like that. Okay, so the bottom number on the fraction, is your index value when you rewrite it as a root. All right, so in just simple terms, this goes for everything.
My apologies. Message in the office for Ashley Becker, please. Ashley Becker.
That is the nth root of a to the m. Okay, so that's the nth root of a to the m. Now, your task that you're going to be given today is going to be to write them from here to here and here to there. Okay, so we're going to work through that today, and then we're going to do a bit of simplifying, and then we're going to write them as mixed radicals and whole radicals, and I'll explain that to you in a second. All right, so the first thing that we have to be able to do is pencil, paper, on the board in your book. Okay, so first thing let's get used to is writing it one way and then back the other way. So let's start with that. Okay, so we have 32 to the 1/2. And we want to write that as a rooted value. Okay, so what is my index value here? 2. And because it's a 2, I don't have to root it. It's assumed for this one. So I write it as square root 32. What is the actual, on the 32 inside the square root, what is the actual exponent on it? 1. It's 1. That's right. It's this guy right here. Okay, so that's good. Let's try another one. 16 2/3. Okay, so 16 to the 2/3. Try it on your own. Write it out. Cube root 16 squared. I should have a cool over here. Across. Cool. You know that. It gets cold and it goes in. All right, good so far. Now, okay, rewrite that. Yeah. Okay. All right. Any questions about writing them as from fractions as your exponents to root values? We okay? Right. So now we're going to do it the other way. Now we're going to take a rooted value and we're going to write it as a fraction. Okay. So what is that one going to be?
6 to the 2/3.
6 to the 2/3.
Yeah.
Do we agree with Elijah?
Yeah.
Yeah? Anybody want to disagree with Elijah? Jack, you and I are on the same page. Really? What should it be?
6 to 3/2.
Right. Remember, the index value has to go on the bottom of the fraction. That index value right there is that. So it goes on the bottom of the fraction. 6 to the 3 over 2. Okay? All right, now 2 cube root 4 equals. Oh, hold on a second. I'm one ahead of myself here, okay? But it is cube root 5 squared. Okay? Elijah, want to redeem yourself?
Yeah. Would be 5 to the 2 over 3.
Yeah. 5 to the 2 over 3. Okay, again, simple. The index value goes as a denominator of the fraction. Okay? One last one. Anybody want to throw it out there? Yeah. 8 to the 3 over 2. Okay, so far so good. That's the easy part. Okay? Now this next part is a little bit more difficult to understand. Once you get into a rhythm of it, you will be fine. But it is also something that we do in grade 11 a lot of. So we have to actually do a good job of it here because we have to do it again. And this is a bit of a struggle. Okay, so there are two types of radicals. The first radical is what we call a mixed radical, which would look like something like this. So that would be a whole number, what we call a coefficient. I have the radical sign, the square root sign, and then I have a value inside it. This value inside it is generally going to be an irrational number. All right, let's discuss this for 1 second. What is an irrational number? Does anybody know what an irrational number is? Anybody? Can somebody give me an irrational number? Can you tell me what an example of an irrational number is? Something that you use a lot of that becomes an irrational number.
Pi.
Thank you. Well done. Pi is an irrational number. What is pi? Do we know what the value of pi is?
Quite.
Sorry?
3.1415.
Okay. What's the thing about pi?
It's endless.
It's endless. An irrational number is a non-repeating, non-terminating, meaning it doesn't end, decimal. Pi is an example of that. It goes forever. The square root of any number that is not a perfect square is also an irrational number. Square root of 2, square root of 3, square root of 5, square root of 6, square root of 7. All of those are irrational numbers. If you plug them into your calculator, they give you a decimal that will go forever. They are known as irrational numbers. So this right here is an irrational number. That B value represents a number that is not a perfect square. Fair enough? Okay. So here's the first thing. I'm actually going to work backwards here because I think it works better. I want to change this value. So this is, again, this is not in the book, or at least it's not in the order of what the book is. I think it's easier to do it this way from having done it before. The square root of 50. Is 50 a perfect square?
No.
No, it's not. So I gave you a list on the first day of all the perfect squares and all the perfect cubes. this is where it's going to come into an advantage for you if you really know that well. What I need for you to do right now is tell me the highest perfect square number that divides evenly into 50. What is the largest perfect square that divides evenly into 50?
25.
25. That is the largest. What do I times 25 by to get 50? 2. So what I'm going to do then is I'm going to rewrite this as square root 25 times square root 2. So I am attempting right now to change a whole radical into a mixed radical. A mixed radical will have a value on the outside called a coefficient and a value on the inside, which is an irrational number, something that can't be broken down. What is the square root of 25? 5. 5 root 2. That is the mixed radical. All right, take out your calculators for a second, please. Bonnie, focus. Take out your calculators. You have a calculator yet? Throw in your calculator the square root of 50. What do we get?
7.07.
The 5. And then the
Okay, go to SD for that. All right, 7 point what?
0.7106.
All right, now what I want you to do is I want you to take 5 times the square root of 2. Did we get the same answer? Yeah, we did, didn't we? So 5 times the square root of 2, a mixed radical, is the same as the square root of 50, a whole radical. Okay? So depending on what it asks for, we need you to write it in the correct form. All right, so let's try this again. What is the largest perfect square that divides evenly into 24?
16 and 2. Or 12 and 2 sections.
Which one's the perfect square?
16.
But you just said 12 and 2. What's the largest perfect square that goes into 24? 8. 8's perfect square? What's the square root of 8?
Yeah.
Okay. Try again. What is it? It is 4. What do I times 4 by to get 24? 6. What is the square root of 4? 2. Two root 6. All right. Now, I asked you on the first day to write down all of the perfect squares. I would suggest you have that in front of you today. So if you have that sheet somewhere, maybe grab it and put it beside you. You didn't do it. Okay. Right along the top here. I'm going to tell you what to write. 1, 4, 9, 16, 25, 56, 49, 64, 81, 100, 121, 144. Okay, and right below that, I want you to write this. 1, 8, 27, 64, 125. So what I just gave you is 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, 6 squared, 7 squared. 1 cubed, 2 cubed, 3 cubed, 4 cubed, 5 cubed. Okay, so let's try this again. Simple one this time. Break that down for me. What is the square root of 8 as a mixed radical? Write it down on your sheet. Yeah, no idea.
I got it. 124.
Those are numbers I picked.
What?
I'm just picking numbers.
Yeah, but what was 24 and 4 and 6?
Because 4 is a perfect square. You know what a perfect square means?
Yeah.
So I have to get a perfect square that is a factor of 24. That means something I can times to get to 624, so that I can change it from this to that. What's a perfect square that goes into 8? 4. 4. What do I times 4 by to get 8? 2. Square root of 4? How many of us got 2 root 2 there? Okay. All right. All right, it's getting a little more complicated, so let's do a couple of them. Oh, I got to show you one more thing. Okay, here's another thing I want to show you. Okay, now, you are generally going to be working with smaller numbers, lower numbers when this happens. So you have to think, okay, well, there's probably only 2 options here. Now I want what? What do you think I'm looking for now? Yes. I want a perfect cube now that is a factor of 24. 8. You only got one option. What is it? 8. 8. What do I times 8 by? 3. So I go cube root 8, cube root 3. Cube root of 8, cube root of 3. What is the cube root of 8? 2. I'm there. Okay. Now, they use this one in the book as one of your examples, so I'm going to give it to you. Actually, I'll start with this. Okay. So the very first thing that I need you to do is ask yourself a question right now. When you see this and it says, turn this into a mixed radical, you ask yourself one question. What is it? What's the first question I've asked you on all of these so far?
What's the closest cube or square?
What is the largest perfect square that goes into 112? Okay, so now go through your list quickly. 4 goes into 112, yeah? So we know we can at least work at that. If that's all you found out right away, you could still do it. And we could keep going and we could break it down a couple times. So that is a possibility. Maybe let's do that. This isn't the largest one, but it's the first one that I think of. Okay, so use your calculators. What do I times 4 by to get to 112? So take 112 divided by 4.
28.
What is it?
28.
28. Okay. What is the square root of 4?
2.
2. So I have 2 root 28. Okay. What is the largest perfect square that goes into 28? Bless you. What's the largest perfect square that goes into 28? 4? Yeah. Okay. How many times does 4 go into 28? 7. All right. So now I have that. So I have 2 times the square root of 4 times the square root of 7. What is the square root of 4 again? 2. So now I have 2 times 2 times root 7. What's 2 times 2? 4. So I have 2 times 2 times root 7. That is 4 root 7. So there is the actual way to get there. Now, was 4 the largest perfect square that went into 112? No. What was it?
49.
No.
All right.
This is going to lead us into the next step, actually, what we have to do next. What is the largest perfect square that goes into 112, that divides into 112? That number in front should indicate what it is. Yeah. Okay. 16 was the largest one. Now, I could have guessed and checked that using my list. Or when I look at this, I could have said, what is that squared? What is 4 squared? 4 squared. It's 16. So therefore, 16 times 7 should give me 112. So that's the way to do it. Okay? So now, I'm going to finish this, and then I'll come back to that exact question on the next page. The next one is this. 4th root of 96. So what number do we know is a 4th root? It has a 4th root to it. You got to think it's small, right? Because what's 3 times 3? Times 3? 27. 27 times 3? 81. So that's 81 is a 4th root. Does it divide evenly into 96? No. So what's the only one that's going to work? 2 to the power of 4. What's 2 to the power of 4? 2 squared is? 4 times 2 is? 8. 8 times 2 is? Does 16 divide into 96?
Yeah.
How many times?
7.
6? So, here's what I do here. 4th root 16 times 4th root 6. What is the 4th root of 16?
4. No, 2.
2. 2, 4th root 6. Again, if you were to look on your calculator and you took 2 and you multiplied it by the 4th root of 6, you would get the same answer as if you took the 4th root of 96. It would give you the same answer. Okay? All right, one more, and then I got to work backwards. Square root of 252. So now, I'm giving this to you. Find the largest perfect square that divides evenly into 252. Go through your list and check the answers to see what goes into it. The largest value that goes into 252 off your list.
$36.
Do we agree?
Yeah.
Yeah, 36 times what gives me
7.
252? 36 times 7. How did you come up with 36?
Guess and check.
Okay. What'd you start with?
The highest,
Which was?
144.
And then you knew that didn't go into it?
Yeah.
Yeah, and then 121, then 100, and then you went all the way down, you got to 36? Yeah, okay, that's fine. That's exactly what I need you to do for right now. Check it. Check it. Now, I could have also checked 4 right away, and then worked 4 through again, like I did at the top there, and it would still work. All right? What is the square root of 36?
6.
6. So what is the square root of 252 as a mixed radical?
6 to the 7.
6 square root 7. Good. Okay. Are we all right so far? Okay. Now, I'm going to use this 112 thing again, and I want to show you to work it backwards. Now, we have to go the other way now. This is where some find this a little more complicated. Now we have to work it the other way. We have a mixed radical, and I want to write it as a whole radical. In this process, it is basically a 2-step process, and you don't need to know anything. All you need to know is what are the 2 steps. There's 2 steps to work this through, and that's it. Okay? The first step is so if this is a square root, I take the square root of that number squared. So I take the square root of that number squared, like that. Now, if I take the number and I square root that, but I'm also squaring it, what happens with the square root and the squared value? They just cancel. That's exactly correct. So I haven't changed the number, have I? I haven't changed the number. The number's still 4. Because the square root of 4 squared is still 4. Because what's 4 squared? 16. What's the square root of 16? Still 4, right? So no matter what, I still have 4 there. I just wrote it a little different. Okay? I still have root 7 here. Now, I cannot multiply a whole number, a real number, a rational number, by a square root. But I can multiply a square root value by a square root value. So now what I want you to do is I want you to take 16, which is 4 squared, and times it by 7. What do you get? 112. Okay. Notice square root of 112. I went all the way through here and I got down to 4 root 7. Now I took 4 root 7 and I worked it back to get to 112. This is a 2-step process that you have to be able to do, and that's it. You don't have to understand a whole pile as long as you know what the 2 steps are. And they're the same every time. Okay? Thank you. Okay, so let's try this again. I'm going to use something different than the book just for a second here. Okay. What is step number 1?
Index into the square root.
It's not an index. It's not an index. The index is the little guy. It's a coefficient.
That's
Alright.
a coefficient in the square root.
Yeah, and
Square it.
square. Exactly. That's all there is. Step number 1. Put the root value over that and square it. That's your first step. I still have root 5 here. Okay. What is 2 squared? 4 times 5? There. 2-step process. That's it. Okay, let's try one that's in the book. All right, this one's tricky. I'm going to do it different than the book because I want you to see something. What do you notice about that? It's decimal. Okay, so there's the first thing that I noticed. So what am I supposed to do here to get it to a whole radical? Entire radical? Square root and square the 2.5. Yeah, I agree. I want you to recognize one other thing before we go any further. What else do you see about that question?
The root, like the 4, that's a perfect square.
Yeah, thank you, Jackson. If you're looking at that question, the first thing you should notice is I got the square root of 4. What's the square root of 4?
2.
2. So if I change it to 2 and I times it by 2.5, what's my entire radical? Square root of 2. Sorry, square root of 4 is 2. 2 times 2.5 is 5. Okay? So that's something I could have just gone and jumped to. I could have changed root 4 to 2. 2 times 2.5 is 5. Now, let's do it the way we just have been learning. So what do? I put the square root and the 2.5 squared there, and then I times that by 4. Okay. 2.5 squared. 6.25. 6.25 times 4 is 25. Thank you. Well done. But what do we know about that?
Also a perfect square.
Also a perfect square. And what is the square root of 25? 5. So we got to that. That is considered an entire radical. Even though there's no radical sign there, there's no square root sign, it is still an entire radical. Okay? All right, so that one was a bit, they tried to trick you there. All right, let's look at this one now. Now what I want you to do is I need you to think this through now. Now what changes? What change do I make to this question from what I've already done?
Cubic instead of square.
Well done, Taylor. Absolutely correct. I cube root it and I cube it instead of square root. So cube root 2 cubed. Cube root 4. Okay. What is 2 cubed? 8. 8 times 4? 32. That is the cube root of 32. Still only a 2-step process. You do the same thing each time. And again, I am spending a lot of time. I'm going a lot longer today because we have to be able to do this well because we have to do it again next year in grade 11. All right. We don't do it in grade 12 at all, but we need to do it now. And we need to do it in grade 11. Okay. One last one. See how confident you are? All right, you try this and see how you make out. Right, because these cancel each other out. Add this to the 5. Okay. First step in the process. Fifth root minus 2 to the 5. Y to the 5?
But it's already updated.
Hmm?
But it is already updated.
You have to do it for this one and this one. This is not for the 2. This 5 is not for that 2. It's for this root.
And then why does it go?
So now I make it for this now.
So why does it still 5?
Because if I take the fifth root of this, and this cancel, and I'm left with minus 2, which is what I started with. Look here. So 2 square root 5. I take the square root and I make it 2 squared. So that this and this cancel out and leaves you with 2. This one has a cube on it. So I have to make this the cube root of 2 cubed. All right? We'll have to work through this after because you're not following. Okay. What is 2 to the 5th? Negative 32. Negative 32 times 3 is? Did we get that right? Yeah? Okay. How we feel about this? So 2 steps to get it to that point. Okay? All right. That'll be our work for tomorrow. I'm going to go through a couple more examples tomorrow so like one of the things I like to do is I like to show you it on one day and then come back to it and show you a couple more examples the next day because then it's not brand new the next day. It'll have taken some time to sink in to do it. Okay. All right. So look on page 72 now. That is what you were working on yesterday. I need you to, number 3 is going to be difficult. That's why the star is there. But I need you to get to the end of number 5 at the very least before you move on to the next section. Is there any questions in there that you want to see? Any questions in there that you want to go over on the board today? Girls? 2E? Okay. All right. Okay, so let's work on 2E. So I have A squared. So I have all right. What I probably would do here, and again, it's up to you how you want to approach this question. I would most likely, and again, it's what I'm comfortable with. So this is what I'm going to do. I'm going to take that negative 1.5 and I'm going to times it by this, this, and this to start with. Okay? So this is going to give me a to the negative 3, b to the negative 1.5, and on the bottom I have ab to the negative 4.5. Now again, you do not have to do it this way. You could work inside the brackets first if you want. You could transfer that 3 through the brackets and then do your subtraction. I mean, I can show you that too after because somebody might have done that. All right, so now at this point, I'm going to rewrite these guys out again. So here's what I have. I have a to the negative 3, b to the negative 1.5, a to the negative 4.5, b to the negative 4.5. Okay.
Why 3?
Why what? Sorry.
Why negative 3?
Negative 1.5 times 2. Yes, no? Negative 1.5 times 2 is negative 3. This times this. Okay? It's a power to a power. Follow? Yep. Okay. What do I do with the exponents now? I'm going to subtract. So I have negative 3. So let's look at this part right here. I'm going to subtract those exponents. Negative 3 subtract negative 4.5. Just going to write that over here so you can see it. So that's the exponents on A. What is negative 3 subtract the negative 4.5? David? Okay. Because it's a subtract a negative, what do I do? Change it to a positive. So I have negative 3 add 4.5. What is negative 3 add 4.5? 1.5. So A, 1.5. That's what I have right there. Now the B, I have negative 1.5. Subtract negative 4.5. Again, what do I do with the 4.5? So I have that. What is negative 1.5? Add 4.5. 3. There's the answer. Okay. Questions about that? Makes sense? Are you unsure of how to start it? Okay. That's exactly what I would expect. But you just start. Just do it whatever way you think, and then let's see if you can just work from there. I might have done this different. I might have taken, I'll just show you this. I might have just left this like this. A squared B over A cubed B cubed negative 1.5. Might have done that. Okay. So all I've done at that point is put the 3 on both of these. Now subtract that. That gives me A, negative 1. Yes?
Yes.
B, what is it?
Negative 2.
Negative 2 and negative 1.5. And then I multiply power to a power. So I have A 1.5, B 3. That might be an easier way to do it. Okay? There's definitely less work doing it that way. The part that you will struggle with, and most of you will have this issue, we don't work a lot with integers and we don't work enough with fractions. Everybody hates fractions. Nobody likes integers. Math is tough, right? Okay, you good? Danny?
Yeah.
All right, you wanted F as well, correct?
Yeah.
Or no?
Oh, we could probably try.
You want to try it now that you watched what we did there? Okay, can I give you a quick hint? Let me give you one hint on that question, Danny. Change 25 to 5 squared and 16 to 4 squared. And then work it through the way we did at the board there. Okay? All right. Anybody else have questions off that page? We want to be to the end at 5 today.
Oh, what about 2C?
Okay. So we've got y to the 2/3 to the -2. And y to the 1/2 to the -4. Does that look right?
Yeah.
Okay. What do you do with a power to a power, Dryden? Power to a power.
Oh, yeah, multiply them.
Got me?
Yeah.
Okay. So let's do that here. -4 times 1/2
So you times it 2.
is -2.
So you do it -2.
Got me? Okay. Now I have a value divided by a value. So a base divided by a base. What do I do with those exponents?
Subtract them. Huh?
I do now. Yes. So now I'm going to get y equals, or y to the power up. So I have -4/3 subtract -2. That's what I have. Okay. I need a common denominator, right? What's the common denominator?
Six.
Could be. There's a lower one than that.
You get 0.2.
What do both 1 and 3 go into?
Could you subtract?
Three.
Yeah.
So it's 2.
So if my common denominator is 3, what do I have to times this by to get to 3?
3.
And this then?
3.
So then I have 6/3 like that. -4 add 6 is 2. There's your answer. Okay, so what I suggest to you is make sure you know the rules, or at least have the exponent rules beside you. So that you know when you see a power to a power, when you see a quotient, when you see the product, you know to subtract or add.
Yeah, I just didn't know how to start it.
Okay? So I see that power to a power, I'm multiplying the exponents. That's the way I start. Okay? Anybody else? Jack? Yep. Okay.